You have to ask yourself, are you going to be okay with this amount of debt to be able to, print slightly faster? All right, hello everyone. Welcome to another episode of Nathan Builds Robots. Now, Bambu Lab didn't send me my H2D in the mail. It must have gotten lost somewhere. Not sure what happened with that. But basically everything about the machine has been leaked already. We're going to talk about the price, all the features, and I'm going to cover all the things that the Bambu Lab Shills don't want you to know. So Bambu Lab put together this little advent calendar where they were trickling out little bits of information here and there, and now everything is released, and basically all of it I already told you about in my previous video. So those of you who frequently tune into the definitive source of 3D printing news, you're already in the know. But there's some new information that's come out, so let's just go over that real quick. So they released this diagram of all the motors and gears that are on this machine. It's a pretty clever system where they can switch between the left and right extrusion using a single motor. And both hot ends share a common extruder motor, which helps cut down on weight a little bit and counteract the fact that they're having to add a couple of extra motors on here. So you can see there's a motor up here which is used to switch from the left extruder arm to the right extruder arm. And then there's another motor down here that's used to switch between the left hot end and the right hot end in terms of deploying one or the other. They always want to lift up the one that's not active so that it's not dragging across the part and accidentally depositing some of the wrong material where it shouldn't be, which could affect layer adhesion and coloring. So yeah, they just lift it up out of the way and put a little spatula under it so that it doesn't leak onto your parts. The next thing that they've announced, which I'm kind of excited about, is one of these servo motors. Now, this appears to be not a stepper motor, it's just like a typical brushless DC motor with a little Hall effect encoder on the back here, so this can tell the precise angle of the motor. And I don't think the goal here is to have extra precision compared to a stepper motor. Stepper motors are quite precise and you don't really need that extra resolution. But what you're going to get with this is much higher strength to weight ratio. So this will produce a lot more torque than an equivalently sized stepper motor, which means that when you look at the overall printhead assembly, they're going to cut the motor weight probably in half, which will help keep the weight under control since they're already adding a bunch of other motors and hot ends on here. That's going to drive the weight up, but they're going to save a little bit of weight here by switching to a brushless DC motor. It's actually pretty similar to something that DJI sells, which are these robotics servo motors. You know, it's like a brushless DC motor. This one actually has a gearbox installed. I've bought several of these for various projects over the years, and they're pretty cool. You get really high power density, they're nice and small, and compared to a traditional stepper motor, you're going to get much better strength to weight ratio. Here's some other motors that DJI produces, and these are for propulsion. These don't have an encoder on them because when you're spinning a propeller, for the most part, you don't care what the exact angle of the blades are and like what the motor angle is. But when you look at something like this, where in a robotics application, you want a joint to go to a particular angle, then having an encoder built into the system lets them control exactly what angle things are at. And that's the kind of control that you get with a servo motor that has an encoder built into it. So this will let them cut weight, maybe increase extrusion speeds a little bit, but I think it's mostly about cutting weight. Apparently they're going to add a bunch of cameras inside of the system to be able to scan a pattern here and do some kind of calibration. So you can load up this calibration sheet into the machine and then it can scan it with the printhead, moving it around and having some closed loop feedback to exactly where the printhead is. And then it can do some kind of transform, some kind of mapping from assigned motor position to actual motor position, and supposedly increase accuracy to some small degree. Now, I don't think this is really necessary for most people because the way that 3D printers in general work is you have a toothed pulley with a timing belt, and basically your accuracy of your machine is pretty tightly controlled. You have much less than 1% of error in the precision of 3D printed parts because you manufacture the belt in such a way that there's like 20 teeth in an inch of belt. I'm just using that as an example. Usually it's like a 2mm pitch. In some Bambu Lab machines, they use like a 1 or 1.5mm pitch belt. But basically with a stepper motor, you know that one full rotation meters out 20 teeth because there's 20 teeth on one of the little stepper motor pulleys. And you can basically be very precise with how you're moving things around with an open loop control system. and it really hasn't been too much of an issue for most people. So, I'm not sure exactly what they're trying to sell here, and if we remember back to the AI LiDAR scanning that they advertised on the X1C, I'm not sure how that ended up working out, but really the LiDAR just ended up being used for scanning the little calibration pattern. So I'm not sure if this is going to really increase accuracy a significant amount over a normal 3D printer, but it's just another marketing thing they can advertise. So you see it here. Heating is not drying, so apparently there's some kind of dehumidifier here. It's either circulating air or they might be using some kind of membrane filter to be able to pull moisture out of the whole system and help keep things dry and warm. So pretty cool stuff there. Some people will complain about traditional dry boxes not being sufficient because when you heat things up and evaporate the moisture doesn't have anywhere to go. But these aren't hermetically sealed boxes, so you end up with a little bit of leakage coming out of there. In any case, it's nice to see this advanced technology, but I wonder what they're going to charge for having this premium feature. This is probably on the AMS Pro or AMS HT. Now, I think there will be a couple different versions of the AMS coming out. One version of the AMS is going to have additional spools, and another version of the AMS will be for higher temperatures. So we'll see what comes out tomorrow. And then the last thing they have here is borderline blasphemy. They're quoting the Bible here saying, "Let there be light." It's a little weird to be quoting Bible verses to help market your 3D printers, but whatever, I guess that's cool. I talked about this quite extensively in my last video. I'm not a huge fan of laser cutters because they produce a lot of smoke, which can make a mess in the machine that you're using it in. It also has the potential to be much more dangerous than the usual emissions that are coming off of a 3D printer as it's working. So if you're cutting something like PVC, this is rumored to have some kind of vinyl cutting module in here. If you accidentally load up some vinyl because you have it laying around and you're used to using this in the machine, then you end up cutting the vinyl with the laser, you're going to release some acidic gases into the air that could be very harmful to your health. So you want to definitely set up ventilation and have a whole primer on how to use lasers safely if you're going to get one of these. Also, here we can see we've got an A1 style heater system. I'm not sure what kind of flow rates this can push. This might be a limiting factor in how fast you can actually print with the machine. So we'll have to see what kind of volumetric flow rates we can get out of it. Also, we had some people snooping around on the elements on the Bambu Lab website, and we had a bunch of this information get leaked, which was supposedly loaded into a secret area of the website, not really displayed on any particular page, but they were able to find all this information hidden on the web elements on the website. If you press F12, it pops up this little side menu, and you can see kind of what's going on behind the scenes in your web browser and all the stuff that's being loaded on the web page that you're looking at. I'm guessing we had some web designers in the Bambu Lab community inspecting that, and they were able to find all this information. So let's look over it now. All right, so the main thing here is that this actually isn't that large of a printer. When you look at the size, this is 300 by 320 by 325 if you want to use the dual nozzle setup. If you're just using a single nozzle, it's only 325 by 320 by 325. That's quite a bit smaller than the Creality K2 Plus and the Prusa XL, which are kind of, in theory, this machine's main competitors. A lot of people, they weren't interested in seeing a laser. They weren't interested in any of this other wacky stuff that they're throwing into this machine. They just wanted a larger Bambu Lab printer. And while this machine is larger, there's still larger options on the market in the K2 and the Prusa XL. So it's not really going to blow anyone away in terms of the size of the machine. It's a pretty typical size at this point in time. Now, you might hear people talk about this being a helmet class printer. I don't know what that means. Is printing helmets a common thing that people do? And if so, what would these helmets be used for? I guess they're just for cosplay or decorations, but you couldn't print anything with like horns on it or like a spike on the hat. I guess you can print helmets with it, and that's like a big thing that the kids want to do these days. I have kind of a big head, so I might need a larger printer to be able to fit that. All this brain volume won't fit inside of such a tiny printer. I'll have to use something like the K2 or the Under 5 Max. Not the biggest printer in the world here. Then we have the weight and the physical dimensions. So this weight is roughly the same as the K2 Plus, 31 kilograms or about 75 pounds. That's quite heavy. Someone like me, I'm not going to have an issue moving it, but if you struggle with large heavy objects, then you might have an issue moving this thing around. Basically the same as the K2 Plus. In terms of the max nozzle temperature, again about the same as the K2 Plus. Filament cutters built in, same as the K2 Plus. Toolhead max speed. Now this is kind of interesting. On most Core XY printers, the max toolhead speed is between like 400 and 600 millimeters per second. I think on the Ender 5 Max, it's 700 millimeters per second. On this machine, it's 1,000 millimeters per second. In practice, this doesn't actually end up increasing your print speeds that much, because the tool head's going to be moving much slower than that when you're actually printing. This is just going to speed up quick travel moves. But then again, the tool head acceleration isn't that much higher than what we've seen on other printers. So I think you're still going to be acceleration limited for most moves that the print head is going to do. So in terms of, having a fancy large number here, pretty cool. But in terms of actual practical speed, I don't think it's going to make that much of a difference. Then we've got active chamber heating, goes up to 65 degrees Celsius. Let me just look up the YouTube. This Creality page is out of control. They really blew the budget on this thing. There's all sorts of video. They hired these actors and models to do things, and geez, now I can't find the basic information that I'm interested. Hold on. I think if we go to the buy now, this will go to my more simple interface. No, wow, it just goes straight to buying it. This is confusing. Okay, come on. Where can I see the actual specs of the machine? I don't like this new website. I mean, it's great for marketing, I guess, but I'm used to things being a little simpler and more engineering. I want to see like graphs and tables. Okay, here we go. So if we look at the K2 Plus, it actually has a higher max acceleration than the H2D. And I think this acceleration is going to make a bigger difference in practical printing in terms of speeding things up, because it has a lower max speed, but it's going to be able to get to that max speed faster. Also, K2 Plus is slightly heavier, it being a slightly bigger printer. I guess that makes sense. Nozzle temperature is 350, chamber temperature is 60. So the Bambu Lab H2D is going to be 5 degrees warmer for the chamber temperature. I'm not sure what the material cutoff temperatures are. I've been able to print polycarbonate in my K2 Plus. I assume you'll be able to do the same type of materials in the H2D. And if you want something that's really truly high temperature, I think you're going to be looking at something that goes up to like 90 degrees. One example of this would be the Prusa HT90. This goes up to 90 degrees, so you can print those like really demanding high temperature filaments. But also having that dual nozzle setup is really going to help for printing soluble materials. And both the K2 Plus and the HT90 aren't going to be ideal at printing soluble support materials. So this machine will excel in that regard, but I mean, we're seeing less and less soluble support material these days, just because that material is expensive, it's difficult to upkeep, it has to be kept dry, and it really readily absorbs moisture. After all, if something's going to dissolve in water, it needs to absorb that water and interact with it in some way. So the material is just inherently kind of hygroscopic. It absorbs water in the atmosphere. So it's really not great. I think what you'd see most often is this type of printing that the Prusa XL first made popular, where you're using PETG support material to help make easy breakaway from PLA parts. And that's going to be much cheaper and easier to use than actual soluble support material. Although you will have that option with the H2D, which is, a pretty advanced feature, costly feature, and something that you usually use on more engineering grade machines. Now this one actually has a HEPA rated filter, which I appreciate. Got to get that HEPA filter action going. That's going to help make sure that you're capturing any particles in the air inside of the machine and when you're exhausting it. However, having a HEPA rated filter doesn't mean anything if you don't have proper sealing all around the machine, both around the fans and the HEPA filters and everything, to make sure that you're not having air leakage, because you can have the best filter in the world, but if there's air leaking out anywhere, then it's, those particles are just going to get out in the room. So we'll have to wait and see how good the filtration and the sealing is on that unit. I mean, in any case, if I'm running any type of laser, I'm going to want to ventilate it outside. I know some companies offer these air scrubbing units where you can just filter the air that's coming off of your laser cutter, but I really think you should be venting that stuff outside. Venting outside is just the best way to deal with that stuff. Let Mother Nature take care of it. All right, and then they're saying they have closed loop control for all the fans. This isn't anything that special. I mean, like any type of computer fan has closed loop control because they've got 4 pins and one of them is a tachometer and it can tell how fast the fan is spinning. It's been pretty common to see much cheaper fans spec'd out for 3D printers where they just have 2 pins, but more and more often we've been seeing closed loop control fans that are just like traditional computer hardware where they've got 4 pins. You can do PWM speed control on them and read out how fast they're spinning. I like these descriptions of supported filament types. Only positive words here. Optimal, superior, and ideal. I mean, are we describing cuts of diamonds or are we describing what materials it's going to be used for? It could just say supported for all 4 of these classes, but I mean, these are all just synonyms for the same thing, saying that it can handle it and print it well. All right, and then let's see. Sensors. We've got a live view camera, a nozzle camera, a bird's eye camera, a tool head camera, a door sensor, a filament runout sensor. Okay, so we've got all sorts of cameras, and we've actually got 4 cameras here. So what is the live view camera? I assume that's just like your camera that's off to the side looking at everything. Then a nozzle camera, that would be just like a really small camera that's taking a really close look at what's happening at the nozzle. We've seen sometimes people upgrade their printers with those. They're pretty cool. They let you see some interesting stuff, and I assume for any type of debugging, it'd be nice to see exactly what's going on with the tip of the nozzle. That way it can see exactly how the purging is going, how it's laying down filament. Here's a bird's eye camera. I'm not sure what that means. When I think of a bird's eye view, I think of like a kind of a downward looking perspective where you can see everything that's going on. And this is going to be a higher resolution. That's pretty close to 4K. So maybe we'll get some better time lapses with that. Then a tool head camera, which is, I assume, something that's just kind of looking downwards on the tool head. So the tool head can go and inspect things, which is a pretty common feature on laser cutters. But now we're going to see it on a 3D printer. Door sensor, filament runout sensor, filament tangle sensor, filament odometry, supported with AMS, and power loss recovery. So we've got all sorts of sensors here. And onboard storage. Oh, it has a USB port. My God. I thought they would never do it. So I'm pumped about that. Normally they've been forcing everyone to use these tiny little micro SD cards. Touchscreen, decent resolution and size. This looks like it's got 2 processors on here. Oh wow, it's got 3 processors. It's got a dual core, single core, and a quad core. Now, I guess the application processor, that's what's going to be on the touchscreen, handling all of the kind of the big stuff. That'll be handling all the cloud communication stuff and the Wi-Fi. Then we've got a motion controller, which is probably going to be for everything on the printer. Then we'll have a secondary motion controller, which will be just for the printhead, and a neural processing unit. Wow, so it's got AI built into it. We'll see how that works. Then we've got Bambu Studio. Supports other third-party slicers, e.g. Prusa Slicer, Cura. Some advanced features may not work on third-party. Okay, notably missing here is Orca Slicer. I think Bambu Lab had a falling out with Orca Slicer over their new updated privacy policy. And I was actually just looking at their terms of use here. Interestingly enough, if your obligations as a person using a Bambu Lab printer is you're not allowed to develop software or design, develop, manufacture, sell, or license third-party devices accessories associated with Bambu Lab product without Bambu Lab's prior consent. I'm not sure what that means, but maybe you're not allowed to does this mean you're not allowed to produce and sell upgrades for Bambu Lab printers? Yeah, so here's the big issue that I have with Bambu Lab printers is they're basically a massive data harvesting operation where they're gathering all of this data on how you use your printer and they're using that to improve their product. This is interesting. If you violate the terms of the agreement, They may result in the deactivation of your account and loss or restriction of the access to the content associated with the product. So once it is terminated, you must stop using the product and delete all the software and associated materials already copied and or installed on your Bambu Lab device or computer immediately. So does that mean they're going to take away your right to use the printer? I'm not sure what that means. In no event shall Bambu Lab's total liability to you for all damages exceed the amount you paid for your Bambu Lab product, other than those that may be required by applicable law in cases involving death or personal injury from Bambu Lab's negligence. Yeah, the terms of use and privacy policy have some pretty worrying stuff. I don't know if it's just that I haven't read enough privacy policies, but this seems pretty serious. One thing that I'm a little concerned about with this privacy policy is that Bambu Lab may disclose your personal information with or without further consent when permitted or required by applicable laws or regulations. I read their terms of service a while ago, and this clause has been in there the whole time. Now keep in mind, this personal information includes your CAD data and the stuff that you've printed on your printer. So, basically if the government comes and asks Bambu Lab, like, hey, what has this person printed on their printer? If they have records of that, they might be required to share it with various governments around the world, which is not something that I want to deal with, so that's why I just use all of my printers offline. Don't use any cloud services. Now, in terms of pricing, Bambu Lab is not very original. They like to copy Prusa for everything that they do. Now, Prusa's kind of run-of-the-mill 3D printers are usually about $1,200 assembled, and that's what the Bambu Lab X1C sold for when it first launched. Then they came out with the Bambu Lab A1 Mini, which they sold for $459 as a pre-assembled machine with the AMS Lite unit. So again, they're kind of borrowing the name, A1 Mini, and the price of $459. They're always trying to clown on Prusa in some way. And now I think the latest model that they're launching, it's also going to be a play on Prusa pricing. This Prusa is $2,000, $1,999. I think that's what they're going to charge for the base model of the Bambu Lab H2D. And that's going to be without any AMS or any lasers, just like the base 3D printer. We're going to be looking at $1,999. And then, if you add the AMS Pro and the laser cutters and the vinyl cutter and all the add-ons, what could that total come to? Well, we might see a reflection in Bambu Lab pricing as a direct copy of one of Prusa's price points. Now, this could just be a lack of originality. I mean, after all, Bambu Lab basically took all of the source code for doing multicolor 3D printing and took it without giving barely a hint of credit in any of their marketing materials that, hey, Prusa developed all this and we're just borrowing it and using it for our printer. And then they're stealing the price points, and they just can't help themselves. So I really think that's what we're going to see. $19.99 for the base, going up to $34.99 for the fully loaded H2D. That really begs the question, why would you be spending that much on a 3D printer when you can get something that's similar, like an advanced printer like the K2 Plus? This printer retails for $14.99 with the AMS, or I guess it's a CFS unit that Creality completely originally invented, all by themselves. But yeah, if we get the K2 Plus without the CFS, it's actually a pretty competitive product compared to the H2D because it costs $700 less, and it doesn't have the dual nozzle system, but I'm guessing that most of you are just going to be printing with one color anyways. And if you want a little splash of color, you can just get the CFS combo on there. Some other ways that the K2 excels, it's larger, it's running open source-ish software. You can get in there and modify a bunch of stuff because it's running a version of Clipper on this machine. Creality is really open to third-party mods, so if you want to change things on this machine, you should be able to do that without getting Bambu Lab's approval first. And this is just a much less expensive printer overall. It seems to be purpose-built for one purpose, which is being a pretty good 3D printer. Now, I've printed several hundred hours on my K2 Plus that Corelli sent for me for testing and review, so I'm pretty happy with mine. I've printed a ton of PLA, and lately I've been printing out some polycarbonate parts. I'm actually printing some Bambu Lab polycarbonate that I picked up a while ago, and it prints quite well on this machine. And it works great in an offline workflow. I don't hook up any of my printers to the cloud, so I'm just using a USB drive and transferring my files that way. One thing that was missing on the features list when I was looking at this before, it's saying that it doesn't have Ethernet. So the K2, I believe, has Ethernet. The H2D is not going with an Ethernet option, it's just going to have Wi-Fi. Here we can see we've got a 10 watt laser module, as well as a 40 watt laser module, which is more than I was expecting them to throw on there. But these lasers are not super expensive anymore. And this is where we're going to see that 1000 millimeters per second. You're rarely going to be printing at these speeds, 1000 millimeters a second, when you're doing laser rastering where it's going back and forth and like firing the laser as it's going back and forth to reproduce pictures and stuff. That speed is going to be somewhat useful. This 10 watt laser module will be useful for cutting through smaller material. It says it can only do 5 millimeters of basswood plywood, which is basically balsa wood. So only 5 millimeters, and then this 40 watt module should be able to do up to 15 millimeters. Now keep in mind with lasers there is somewhat of a fire risk, like you could ignite something in the chamber, so I would really recommend only using this when you're watching the machine. There might be some kind of fire detection functionality in the printhead, and having those part fans blowing on it should help blow out any fires that get started. But yeah, it's just something you're going to want to keep your eye on. Lasers aren't something you want to mess around with. And this is a pretty small engraving area. Oh, and apparently it's got micro LiDAR maybe built into this laser module. And then there's a cutting module, which I guess is going to be like a vinyl and paper cutter. That could be pretty fun as well. So I think there's a lot of interesting things on here. I think something a lot of people are concerned about is there's a saying, jack of all trades, master of none. We'll see how it turns out. I mean, if they can make the printer portion of this machine good, then I think they'll be onto something. If it's too compromised and overpriced based on all these extra features that they're adding, then I could see a lot of consumers having an issue with that. One issue that seems kind of unavoidable at this point is the pricing. With all these features they're adding on here, you know, it's just driving the price up. Also, repairability. If anything on here breaks, you're going to have to diagnose it and fix it, and there's not going to be any third-party supplier of any of these parts, so you're going to have to go through Bambu Lab. Once your warranty is up, then you'll have to buy the parts yourselves. I mean, if you've owned a Bambu Lab printer, you know the deal. Fortunately, they provide a lot of spare parts, but with how much tech is packed into this hot end, I imagine this would be pretty expensive to replace a lot of this stuff. And if you have a situation like a blob of death, this kind of thing, it's commonly referred to as a blob of death because it's a giant blob that basically kills your printer and makes it inoperable. It's usually caused by a leak somewhere in one of the heat breaks or the nozzles, and it just like shoots molten material out everywhere. It looks like it's kind of pushed this fan down, and sometimes it can break things off, and you have to replace a couple of parts. But if you have a tool head that's as complicated as this, with all of these laser modules, all of these fan ducts, if you've got the laser module attached to the front, it could get caught up in all of this. All this complex extruder mechanisms. If that gets gunked up by a gigantic blob of plastic, you have to replace all of this stuff. How much is that going to cost? I'm curious to see what replacement parts are going to run for this thing, because I would imagine this whole tool head all added up, because you've got these tiny little MGN rails here, you've got multiple hot ends, multiple PCBs, multiple gearboxes and gear motors and extruder teeth and everything. I could easily see this costing $200 to get a replacement. So yeah, it's not great in terms of cost to get that repaired. It's probably going to be somewhat complex to fix because the previous versions of Bambu Lab machines haven't been the best to work on. Hopefully they've been able to improve that. We'll see if it's been a priority for them. And then again, you've got these cameras and stuff all right next to this hot end, so all of that could get caught up in some kind of blob of death accident. But maybe you've got all those extra sensors and cameras on there that can watch out for that and stop the machine in that event. But where is all that AI processing going to happen? Is it going to require Bambu Lab to constantly beam what's going on your printer up to the cloud, so it's constantly monitoring it? So it would be, like a constant internet connection, constantly sending data up to the cloud. Again, not sure about that. Okay, so the last thing I want to tell you guys is I've just loaded up 3 X1Cs into the cart here to simulate what the top end H2D might cost. All of a sudden you're looking at like a $4,000 3D printer. Now you got to ask yourself, are you in the market for a $4,000 3D printer? Can you afford a $4,000 3D printer? Do you want to load up your credit card with $4,000 worth of debt so that you can have access to this new machine? For me, the answer is no. I'm not really interested in getting a printer that's that expensive. Now, I'm no stranger to splurging on tech devices that I find that would be useful for me to get my job done, do various functions of my YouTubing. Like I probably spend this much on camera gear on an annual basis. Fortunately, a lot of you tune into my YouTube videos, and that helps cover the cost there. You have to ask yourself, are you going to be okay with this amount of debt to be able to, print slightly faster, be part of the cool kids club and have the same 3D printer as all your favorite YouTubers? And are you interested in doing a payment plan with Klarna? You just go there and get yourself set up with a payment plan. You pay $400 a month for the year or something like that. I mean, if you're going to pay this off in a year, that's probably about the same as a car payment. So do you want to pay as much as you would pay for a car? And do they sell an extended warranty for these things? Yeah, these printers, the pricing is getting quite out of hand. The XL is more marketed as a kind of like a prosumer/professional thing. So I guess they're marketing it towards people that are making money with their printers. I have a hard time believing that typical people are dropping $3,500 on a Prusa XL frequently. The K2, this is kind of in the sweet spot of cost. I feel like this is a nice amount to splurge on a new little tech device that you're going to use for a while. But if you're looking at up to $3,000, $4,000 for one of these things, it's pretty expensive. Especially when you think about it, that at the end of the day, all this is a 3D printer that can print 325 by 325 by 325. It's not a particularly big printer. It's not going to be that much faster than the next best thing. And yeah, I mean, if there's a specific use case you have for it, like you do a lot of 2-color prints that are of a certain size and you think that this will be really great in your print farm setup or whatever, I could definitely see a business case for it. But in terms of a hobby machine, this is getting to be pretty expensive for a hobby. Back in my day, when I first got started with this new wave of 3D printing, you were looking at things like the Ender 3 that costs $180 on Amazon. Now we're looking at printers that cost over $2,000, close to $4,000. And you have to ask yourself, like, okay, you've kind of been ratcheting up the cost you've been paying for this stuff. What is your wife or girlfriend going to think when they see a $4,000 bill on the credit card? Is this thing even going to be serviceable in 2 years when you're done using it or when the warranty runs out? I think in the US it might be 1 year and in the EU it's 2 years. In any case, the warranty doesn't last all that long. And then when you're out of warranty, you have to buy replacement parts from Bambu Lab. So, this looks like a pretty expensive setup. My advice to you guys is don't buy anything that you can't afford, especially something this expensive. I was kind of on the border of recommending the K2 Plus, which is, $1,300. And Creality usually has sales, so you can probably find it for less than that on a somewhat regular basis. But, $3,500. Oof, that's a lot. So think about it. Think about if that's what you really want to do with your money. This is like a solid vacation budget if you want to go to Europe or Japan or something and do something interesting with your life instead of just hanging out in your man cave and talking with other Bambu Lab people on Reddit. Just think about how much money that is. Also, your favorite content creators are probably getting a pretty sizable share of this in the affiliate program. Now, I wouldn't know because I'm no longer in the affiliate program for Bambu Lab, but the industry standard is usually between like 3 and 10%. So do you think maybe the people who are recommending this printer might have a financial incentive to talk about how great this machine is and how it absolutely has to be the next machine in your collection? And are they going to encourage you to maybe tap the brakes a little bit and think about, maybe I shouldn't buy this right away while I'm all wrapped up in the hype cycle? Maybe you should spend a couple of months thinking about it before you pull the trigger, because, well, let's be honest, most new product launches usually have an issue or two here and there. So you might end up having to do a recall or something and having to replace parts. And we all know how that turned out with the Bambu Lab A1 bed cables. So yeah, I think this is a little bit much to be paying for a 3D printer. Personally, I wouldn't buy anything over $1,000. Creality sent me the K2 Plus. I've printed hundreds of hours on it. I think it's a pretty good machine, but ultimately I probably wouldn't even buy that thing, even though I like using it, just because of the pretty high MSRP. And I think the sweet spot for 3D printer pricing is between $200 and $1,000. And anything more than that, you're just like, you're kind of throwing your money away. You can get the A1 Mini for around $200. You can get like these entry-level Ender 3s or the Elegoo Centauri Carbon. All of these great printers in the $200 to $300 range, and they do 90% of what you need to do. Then let's say you want multicolor, you can start looking at something a little more expensive, like the FlashForge Adventure 5X, or any of the low-end Bambu Lab things with multicolor modules, or the Creality High, or the Anycubic Cobra S, whatever. Yeah, there's just so many options on the market at this point, and they're all starting below $500. So unless you absolutely need this kind of capability, I would probably try and stay away from, going into generational debt just so that you can have a 3D printer. Okay, well, if you've enjoyed this video, thanks for watching. I hope you guys got what you needed out of this video, and it was somewhat entertaining. And yeah, let me know in the comments below what you think. And tomorrow we're going to have all of the Shilltastic videos out there on the internet where Bambu Lab hand-selected people from their marketing department to make videos for them. And I think we're going to see more than just our usual 3D printer community. I think Bambu Lab is also going to be sponsoring videos on larger channels like, I don't know, Linus Tech Tips or whatever these like more expensive, more broader audience tech channels are doing. I think we'll see some of those. And Bambu Lab is not so shy about doing sponsored videos with them, but us poor little 3D printer YouTubers just work for scraps. We work for affiliate income. We don't ask for sponsorships. Anyways, on that note, I'm going to sign off on this video. Just remember, think about all the other things you can do with $3,000 before you hit the buy button on one of these. Okay, thanks for watching this episode of Nathan Builds Robots. And I'll see you in the next one.